You might think of the night sky as a permanent and unchanging backdrop for our lives, but it's not. The sky is filled with things living out lives every bit as beautiful and messy and unique as our own, maybe even more so. Take a star, for example. When a star reaches the end of its life, if it's massive enough, a marvelous transformation occurs. In an instant, the entire star erupts in a brilliant ball of light, billions of times brighter than our own sun. This extraordinary explosion is called a supernova, and they're happening all the time in our universe, a new one every second. By studying the light from these explosions, we can reconstruct the final moments of a star that ended its life in such incredible fashion. Astronomers are getting better and better at finding these explosions, and before too long, we'll get a little too good. For the first time in history, we'll discover more of these explosions than we could ever study in detail, and we'll need to invent new ways to decide where to focus our attention. This is my research, crafting new tools to unravel the mysteries of how a star dies. This might seem like an easy thing to do, but it becomes a lot harder when you have to do it before the explosion fades away. We have a few ideas though. Each person carries the signatures of the environment where they grew up. An accent, a style of dressing, a way of seeing the world. And stars are the same way. They form from the dust and the gas around them, so their lives and their deaths bear the mark of their environment. I'm showing one simple example of this on the slide here. Big stars are found more often than small ones in the arms of spiral galaxies. And the explosions of big stars brighten and dim differently from the explosions of small stars. So if we see an explosion start in a spiral arm, then already we have a sense for what kind of star that explosion came from and how the explosion is going to look. Now, some of these connections we understand, but the vast majority we don't. And by learning the connection between a star and the place where it grew up, we can recognize these signatures at the earliest moments in a star's death to separate the completely normal from the completely unexpected. Upcoming telescopes will discover explosions that we've never seen before. We've constructed a rich tapestry for how we think the universe works, and these weird explosions lie right at the edges of this tapestry. By finding and tugging on these threads, we'll expand our understanding of the secret lives of stars and redefine what we thought was possible. Thank you.